Well, we might as well get started. We'll go over some basic stuff in the beginning for anyone who comes in late. But I want to start by introducing myself. And well, first, thanks for taking time out of your Friday night to be here. I was actually a little worried, 4:30 on a Friday at a conference. When all the people I know here are like, sorry, Julian, I'm not going to be there. I'm drinking beer on my porch. So thank you for being here. So my name is Julian. I'm an academic ambassador with JMP. I also teach statistics at the University of California, San Diego, an intro and an advanced class. How many people were in the session yesterday? The 1 to 3. Oh, several of you. Great. And then the morning session with Mia, a couple of you as well. Great. So you've heard a little bit of the basic stuff I wanted to talk about. But the main purpose of the workshop today is really a getting started workshop. So you've seen what JMP can do, or at least you've heard about it, and you want to see how it works, how it feels. Today was meant to be kind of a hands-on session. Doesn't have to be. I'm actually recording it, so I'll point you to the link later on. If you want to have hands-on session later on watching it, that's fine too. But if you would like to do it now, actually if you go to jump.com, there's this try JMP at the top there. And actually if you scroll down, you can click Start Your Trial Now. It's only a couple little questions on a form you can download. Here it's not terribly fast, so you may not get JMP until halfway through. But if you'd like to try it out, certainly feel free. If you have an older version of JMP, that's fine. JMP 12 is what's out now. And I'll certainly point out some new features, but don't feel like you have to have the newest to actually see what it's about. All right, let me close that here. Did everyone see the projector okay in the back? Not too small. All right, so let me tell you a little bit of the scope of what I wanted to cover today, really where I want us to go. I'm going to certainly talk about JMP basics, so how to get JMP. I've actually already talked about that. That's just getting the demo. Actually, at the end of this, we have some cards, too, for JMP Student Edition. I'll talk about the distinguishing features of Student Edition and regular JMP in a second. But we have a card so you can download it and have I think it's a 2-year trial, Kurt? 2 years. Yeah, so it's 2 years for you to use it. I'll talk about some basic use today. My background's actually, I'm an experimental psychologist, so I think of things in terms of minds. So I'm going to talk about the mind of JMP, which is really just the developers of JMP, how they think about data. I'm going to talk about working with data. Basic stuff, getting data in, how to import, certainly important because you don't have files in JMP format, almost certainly. So how to get data in and also how to make a new table, some basic data manipulation. Then I'm going to talk about some essential tools. These are features that are not the most advanced analyses you can do in JMP, but the things that make your everyday analysis easier. So things like global and local data filters, cutting up your data and looking at pieces of it. Things like bivariables, looking at separations across variables of the same output. And broadcasting commands, column recode, I'll talk about all these things. Then we're going to get to really the essential platforms in JMP. Now there's a lot that JMP can do. It's very, very deep as far as a product. But as far as the intro or even intermediate stats class goes, there's really only a small subset of the platforms in JMP you'll actually need. And these are the ones that are really in Student Edition as well. So GraphBuilder, really the basic graphing platform in JMP. There's Tabulate, so tabulation. Sometimes we just need a table out of our data. It's not a graph. Not even an analysis. We just need crosstabs. JMP has a great facility for that. Then I'm going to talk about distribution and fit Y by X. These are big platforms in JMP, really domains of inquiry. Let's talk about those two. And then fit model and multivariate. A little more advanced, but certainly something you might come across in an intermediate course. And then finally, and actually I'm going to start with this, is the resources we have. When you teach statistics, you don't want to teach software. At least I don't. I enjoy teaching JMP. I love JMP. But I want to teach statistics. I want to teach reasoning. I want my students to leave knowing something about the concepts. Now, that's tough sometimes when you're teaching a new piece of software. And so sort of what we do on the academic team is try to make that a little simpler. And so we have a number of different resources. The one that I'm going to tell you about first is actually the Learning Library. Really a wealth of resources to just drop into your course. So guides and videos. I'm talking about some concept discovery modules. You saw some of these yesterday. And these are really great ways of teaching difficult concepts. Things like sampling distributions, randomization, permutation. And then we'll talk about some of the webinars. So we have a lot of webinars that we do live and actually have recorded. So you can point your students there, or you can watch them yourself. Everything from basic to advanced. So actually, this is a great place to start. I want to actually look at jump.com/learn because after today, you may want to learn more, and this isn't your only opportunity. So let me actually go over to this. Take out that starting parenthesis. Now, the Learning Library is interesting. It's built around really a structure of types of analyses. And so if we talk about a domain, let's say basic inferences, proportions and means, we go to that section, it's not going to have every type of analysis JMP does in this section, but it's going to have the big ones. So for instance, let's say you're teaching paired t-tests and confidence intervals. And you don't want to teach software. You just want to teach the concepts. You're going to make that, it's really a one sample test. You're going to talk about the standard deviation and the different scores, all those things. You want your students to then click on this one-page guide. It'll pull up a PDF. These are all downloadable. You can download them as a set, actually. And it's going to point them to sample data and step-by-step instructions of how to do it in JMP. And so you don't have to teach this part. You just teach them the concepts, and then you can assign as homework, actually, the how to do it in JMP part. Oh, good. That's a little sign I made. Now, you can also, if you have students who aren't particularly interested in reading, and I know some of mine are not, you can have them watch a video. And so these are all fairly short, 2 to 5 minutes. Really meant to be a quick and dirty approach. How to do it in JMP, a little bit about what the output means. Certainly not teaching the concept. That's your job. You want to teach that in the way you want to teach it. These are meant to just cover JMP. And so really a set of resources that let you attach it to really any curriculum. And the benefit here, I don't know how many use textbooks in a class. Several of you probably. Now, you don't probably want to choose a textbook based on what software is in the textbook. At least I don't. I want to choose a textbook on how they teach statistics. Do they cover sums of squares the way I like? So the nice thing about these is you can choose a textbook sort of indifferent to the type of software where they're focused on other things. All right, so that's at jump.com/learn. Now I'll come back to the concept discovery modules, some of those other pieces in just a minute. Because what I want to do now is sort of give you the basic overview of what JMP is, why it works the way it does, and really why it's a product of SAS. And that's actually a question we get a lot of times. Now, how many people have never seen JMP before? First times. Oh, great. So never seen anything. That's fantastic. So let me tell you a little bit about JMP. We've actually been in JMP this whole time. This is a journal. You can build these in JMP as a way to teach classes or to teach things. I like them for outlines. But let's talk about just why JMP is what it is. And I'm going to pull up a data set. And to do this, I just want to first talk about the structure of JMP. So the anatomy, I would say, before we talk about the way it thinks. And it's going to look pretty friendly. So those of you who have never seen it before, this is going to look similar to things you've seen. It's a spreadsheet. Right? We have rows and columns. The rows in this data set represent tables at a restaurant, and the columns represent different attributes about each table. So the bill amount, the tip amount, whether they use a credit card or not. Now, so those are attributes, and typically in most statistics software, your attributes are across columns, and rows represent units of sampling. Same thing is true in JMP. Now, JMP's a little special, though. There's pieces of JMP that you probably haven't seen before if you've never seen the software. So things like a columns list here. Now, these are the same columns that are across the top. If I select them here, it selects them across the top. But we have this list because there's some attributes of columns we always want to bring attention to. And they're the icons right here. And so those are the modeling types of the variables. The data that, or really the structure of the data that we're measuring. And the way JMP does it is this little blue triangle is set as continuous. So that's interval or ratio scale data, really numeric data. The little red histogram is actually nominal data, so data that's just categories. Now we actually have ordinal as a measurement as well, so if you have ordered categories, you can set that. Now this is special because unlike a lot of statistical software, it's going to pay attention to the modeling type. Because if you think about it, the type of data you have circumscribes a set of possible analyses you can run. And so JMP in its interface, and I'll come back to this in the mind of JMP, it's smart about what it offers you based on the type of data you have. And I think that's unique. Not a lot of software does that. But it's good because you don't have to have menus full of different analyses. JMP knows what to offer you based on the type of data you provide. All right, so that's the basic structure. Now let's talk about the mind. And really, there's only 2 things you need to know about how JMP works. Then I think you'll actually be able to do pretty much everything in JMP. The first is what I just mentioned, modeling type, that it matters. That is, the modeling types of categorical, nominal, and ordinal, or quantitative, continuous, those determine the types of things JMP shows you. Now the second thing you need to know about JMP is that its interface progresses forward. That is, once you produce output, you dig deeper. So when you produce an output in JMP, it's not in a log, it's not in a fixed window. It's actually going to let you continue to progress. And let me just produce some output, and then I'll talk about why JMP works this way. So I'm going to go to a big platform. It's called distribution. This is where you do all univariate or one variable analyses. And JMP's going to ask me in this launch window what columns I want to use. And so I'll take a couple. I'll take tip amount and credit card. Let me just drag tip amount in. I can click credit card or click it into Y. There's different ways to select columns. I'm going to click OK, and we'll get some output. Now, it's pretty basic right now, but I want you to pay attention to a couple things that may be not obvious when you first see it. Now, the first is, on the left, I have a proper histogram. I mean, this is a histogram of data. I can change the scale, it'll change the bins, but that's a histogram. On the right, I really have a frequency distribution plot. Just plotting the frequencies of data. Now jump knew to do those two different plots, because of the data type. One was set as nominal on the right, and one was set as continuous on the left. Now the types of output I get, the quantile, summary statistics, right? That's what I get on the left, but on the right I got frequencies. Jump knows the difference. It knows what to do for these columns. Now I'll come back to this. There's something special about jump, which is everything is linked. So I can click on the yeses and nos, and I can see on the left where those tables are. You can even see in the background, in the table itself, the data table, those observations are connected. So I can even take this weird one. There's a table where somebody tipped $16. Maybe kind of strange. I could actually right-click. I'm going to give it a little marker, because maybe we're going to come back to look at that later. I could even exclude it right there if I wanted. All right, so principally, though, the main point I want to get across here is that the output depended on the type of data we have. Now, what about that second point, the progressive interface? Let me expand this. Now, the context-dependent output is one piece of this. The second piece is these red triangles. And you'll see them actually all over jump. As you're learning jump, click every red triangle. Get to know what's in every one of them. And know that they're going to change depending on the type of data you have. So this red triangle right here, that tip amount, look at the options I have. Things like testing a mean. I could test in a one sample case whether a mean is different from some null hypothesis mean. Or maybe I want to get a normal quantile plot. Right? That makes sense in the context I'm in. Let me turn on that. See what happens. It just pops out right in the same window. So it's an interface. I'm not in a log window kind of format here. I'm actually in a little interface of my data. I'll even turn it back off. Now on the right-hand side, credit card, right, that's a nominal column. It's a different context. Still univariate. We're in the distribution platform. So look at the options I have here. Right, jump knows to offer me different things. It's not offering me a normal quantile plot. It's offering me things like a mosaic plot, a way of representing the share, or testing proportions. It's called testing probabilities here, a one sample chi-square. Right, so jump is contextualizing not only the output, but the options it shows us to dig deeper. And so every one of these red triangles does different things. Down here, I customize the summary statistics. Right, once I produce output, let's say I test a mean here. So I go into a one sample Ttest, let's say. Let's say under the null hypothesis, we've always had tips that are around $4. And so we want to test whether this week maybe they were different. That output gets produced in line. This is something kind of special about jump. Every statistic comes with a graphic. This is a distribution under the null hypothesis, a sampling distribution. And my observed sample mean and the extremes shaded, right, showing me the two-tailed p-value. And notice what happened. I got another p-value, or sorry, another red triangle. So I get another chance to dig deeper. And I can do things like a p-value animation, where I can see what would happen if I specified a different null hypothesis. Or what if my sample size was doubled? Or let's say halved. Let's actually make it even wider. So a higher p-value because I had smaller sample size. So these red triangles let you dig deeper in a way that makes sense. So power animations or things like this. So always click a red triangle. See what's underneath them. All right, so I want to mention one more thing. At this very top, you'll see this on most platforms. And this is a platform output. There's usually a red triangle that applies to the whole platform. And so these have options that apply to really everything you're looking at. And so there's one section we'll come back to, scripts. So you can do scripting in jump if you like, saving scripts for further analyses. But there's an option here in distribution I think you'll probably want, which is called stacking. And let me ask you this question before I do this. How many people like their histograms vertical? Very few of you, I think, are raising your hand. I think it's really neat, and I'll tell you why. If you have lots of output, let's say we're looking at every column at once, our screens are wider than they are tall. It's actually nice. You can see a lot. But when you're teaching, this is an extra step for a student. Even though, I can tell you being a cognitive psychologist, that's more natural. Higher means more high on a scale, whereas if we rotate them to the right is more high. I guess for you it would be this direction. That's a weird cognitive translation, but we're so used to it. So I wanted to point out this option. It's called stacking. And if you stack, everything gets rotated. That's probably more natural for a lot of you. So if you like that better, yeah, more natural. So if you hate the vertical, and I know some of you do, let's set a preference for it. So today we'll never see it as vertical. And let me show you where this is, because there's something about jump I want to point out, which is these are little interfaces. So set jump to be the way you want it to. And I think this is so amazing, because I have mine set up to do specific things. And what's fantastic is jump works the way you think. And you can set this. So let's see how we do this. I'm going to go to platforms. And under the distribution platform, there's a whole settings section here. You can turn on or off whatever you want. I'm going to check stack. And so I want you to see what happens then. So for the rest of today, or until I change it, when we go to distribution, we look at some columns, we're going to get it that way. It's the way that's more natural, I think, for most of you. Everything still works the same way, but we've set JMP to work the way we think. And if you're teaching and you like this better, make your preferences and then send your students your preferences files. And then their JMP works the way that you think they should think. And so JMP doesn't force you into a style, which I think is really unique. And since these are little interfaces, you want them to work the way you think. All right, so those are the two things you need to know about JMP. You're experts now, right? So modeling type matters. When you have a data that's set a certain way, that determines what JMP shows you. And the interface is progressive. It lets you dig deeper as you produce more things. Now, there's one downside to this, and I'll back up and say, why does JMP work this way? And the reason it works this way is JMP was born about 25 years ago now, which is the time the Macintosh was really coming into prevalence. Now, older statistical software, legacy software, was born really when it was a server and client relationship. You had a computer that didn't have much horsepower, so you sent all your commands out to a server, and then it bounced back to you in a log. That was the way statistics worked. That's the way it had to work. But when JMP was born, 1989, I think the date was September 35th or something. So they wanted it to come out in, I guess, Q3. And so they didn't quite make it, so instead they extended September. Fun JMP lore. Do you know what JMP stands for?
No,
John's Macintosh product. Yeah, and so that's part of the history. So John Saul, one of the co-founders of SAS, decided, because of the Mac, it had a mouse now, it's this interactive interface to computing, why don't we do statistics that way? Why can't we make statistics be an interface to data where we can click stuff, where we can drag, where we can interact and touch the data in a way that lets us connect to it in a more deep level? Why do we have this log and a server-based client relationship putting distance between us and our data? Why can't it be fast and interactive? So he made JMP. And that's what it's been since. They didn't really have a name for it, so it was just John's Mac program or John's Mac project. And so to this day, it still honors John, who's still the chief developer of it. After 25 years, he still programs in C++, or I think Fit Model is his baby, which we'll come and talk about later. So that's the history of JMP. That's why it works the way it is. It's built for a modern computing environment. And so it works in a slightly different way. It has this progressive interface, and it can pay attention to things in your data set. Now, there's one downside to this. If you have a menu that has every analysis you can run, and you scroll and scroll, you get to general linear model, and you scroll down, and you find particular variants of each model, that's great. You can find analyses quickly. In JMP, our menus aren't that long. There's distribution, fit y by x, match pairs, tabulate, fit model. These top 5 items cover about 200 different analyses, but maybe you don't know where to look. And this is something I want to point out. It took me a while to find. I've known JMP for about 10 years. And probably it took me 2 years to find this guy. It's called the Statistics Index, under the Help menu. Now write this down. If you're going to learn JMP, Statistics Index, under the Help menu. And here's why it's cool. This is actually every analysis JMP does. And you can type in to a section and find it. So anything you're looking for. If you're looking for, let's say, Cauchy regression, you can run this example. It'll bring up the platform it lives in and show you the output. So the statistics index is great because if you're looking for that very particular analysis, you can find it and quickly get help. You can actually see the script that is underlying it and all the details about it. So that's the statistics index. All right, so that's the mind of JMP. We saw really the anatomy of JMP as well. So pretty straightforward. I want to talk about getting data in. I mean, we've seen one data set, and I pulled that from sample data. Now, if you like some of the sample data, I'll show you where it is. It's actually really great. It comes with about 440 data sets, JMP does. So under sample data in the help menu. And it's nice because they're organized by types of analyses they're good for. So on the one hand, if you're looking to teach something, let's say GraphBuilder, which I'll show you in a second, there's different data sets that are really great for different things. So if you wanted to make a line chart or show Napoleon's March. So you all probably have known this graphic, right? So that's made in GraphBuilder. Or, and we'll come back to this one, this is so cool. So this is Napoleon's March animated in JMP. So there's his army splitting off. And then it's like, oh crap, winter. And now he's going back. Yeah, and his army rejoins. So the nice thing about the statistics index is you can actually click through, these are all saved scripts that are part of the data tables, and you can demonstrate things with them. Now, for our purposes, the ones I'm going to use today, if you want to try later and you're watching this recording, you can just go down to the sample data directory, pick out the exact data set. And so the one I'm using is restaurant tips right now. Now we're going to come back in a little bit and talk about the teaching scripts. Those of you who were in the earlier sessions probably saw these. Under teaching demonstrations, there's lots of neat things. These are more legacy demonstrations, little tiny applets that show certain things. So this is one that shows a least squares line, and you can actually move the points around and see how it affects the line. And it's so cool. So teaching regression is amazing with JMP because you can just, all that interactivity really facilitates concepts. But under the interactive teaching modules, these are the more advanced ones. So really full teaching modules that show concepts like distribution of sample means, confidence intervals. So you can find those all under the sample data index. All right, so that's getting sample data in. How do we get regular data in? You know, nice thing for JMP, it works like all your other software, like Excel, like Word. It's just file open. And as simple as pointing yourself to the sample data directory or any directory, and you can just import data. Now, I'm actually going to go up a level because I want to show you what it looks like when you're pulling in data that's not in JMP format. Because obviously, you probably don't have your data yet in JMP format. And so let's look at a couple examples. So I just went up to import data. This is one level up when you first go to file open. And what I'm going to do is let's open a text file. So bigclass.txt. Now, I want you to see what it's going to do first. I'm showing you this on the Mac. On the PC, it's going to look really similar. The only difference is that these three options, or four options, I guess, are going to be right next to the open button. Now, I want you to see what the options are. So open as text, and I'll just do this. This isn't what you'd want to select. What it's going to do is actually open the text of that file. So it's just a plain text output. Now, this is nice sometimes if you want to see what's in the file before you try to import it. And actually, from here, you can just click Import as Data, and it'll guess and bring it in. So it's as easy as that. But I want to back up because I want to show you the option I like. So when I'm bringing data in, this is one I always suggest to students too. So let me go back to bigclass.txt. And the one I like is data using preview. Because what this will open is the data preview or text preview window. And what this looks like, let me actually move it down, is you have it makes a guess right away of your end of field delimiter, we have tabs, your character set. It usually does a pretty good job from the get-go. But occasionally you may have something else that delineates your rows or columns. So you may have commas or extra spaces. So you can set these all here. You can also pull in subsets. So this is actually nice from a big data perspective. If you have a data set with maybe 10 million rows and you want to take a probabilistic sample of them, you could have every student take their own random sample of 250,000 rows and bring it in. And so there's probability per line. So you can set, or a number of lines per file. And so this is a nice little feature if you want to bring in pieces. But for us, we're actually done. We can just hit Next and Import, and JMP will bring this in just fine. Now, we don't have table header names here, so we'd want to add these in. But notice what JMP did for the column types. Notice that for, anything that has a character in it, it marked it as nominal, which makes sense. If you normally don't enter numbers as characters, 1, 2, and 3 written out. Anything that has a number, it brought in as continuous, which is usually correct. But does anyone have any data where ones and zeros represent males and females? A couple of you, right? Yeah. So be careful with that, because JMP will think those are numeric. I mean, they are numbers, but they represent categories. And JMP will pay attention to that, and it will give you different analyses if they're marked as continuous.
And you can change it?
Exactly. Great question. Yep. Just click right here, and we can set it over. So for instance, a good example is in this big class data set, we often show this with age marked as ordinal. Let me show you why. If I have it as ordinal, and this is actually height and weight, so let me actually go to a different platform I haven't shown you yet, which is called fit y by x. This is a bivariate platform. The way JMP organizes these is univariate for distribution, bivariate for fit y by x. And there's a little legend here. I love this legend. So this is what the modeling type is of the x variable, whether it's continuous or categorical, nominal or ordinal. And this is what the modeling type is of the y variable, continuous or categorical. And this little legend is really what type of analysis output this produces based on the modeling types of the input variables. And so if we take this one, which represents age, 12, 13, 14, we have it marked as ordinal. Let me put that as the x. And let me take this column, the one that represents weight, and put that as the y. Now you maybe didn't see it click over, but it now says one way. It knows we're in this little square here. And the type of output I'm going to get is going to be a window that gives me options related to ANOVA or Ttest. So in this case, this is where we can run that ANOVA. Or we can compare each level to each other. So students Ttest for each combination. Or things like an unequal variances test. Right? That all makes sense if we think of this numbering as categories. Right? If those are just categories, then those are just labels. Now, let me run one analysis. I'll do the means and ANOVA. Put that to the side. Now let's go back to our data set, and I'm going to click on this icon and set it to continuous, the way I think a lot of us think about age. And so let's go back to Analyze, fit y by x. Now just so you don't think I'm cheating, I'm going to click Recall. This will put back in exactly the same specification I did before. But notice JMP designated this as a bivariate. And that's because of the modeling type. It paid attention to it. The output may look pretty similar, but in fact, look at the options. JMP knows this is now the domain of regression. I can fit a line. Or if I want, I can fit, a 5th or 6th degree polynomial. Who knows why anyone would do that, but you can. But it's all right there. And there's something I think I'll mention now, which is the pedagogical value of the organization of JMP. So the mind of JMP is built around these domains of inquiry. It's built around modeling type, circumscribing the set of analyses that make sense. And I think that's nice because I'll tell you, when I teach Ttest, comparing means or Tukey HSDs, I'm also teaching the non-parametric equivalents. I'm teaching Wilcoxons, right? Or my new favorite is the Steele-Dwas. This is a non-parametric Tukey HSD. Now what's cool about the way JMP is, look how close those live. They're one click away in the same platform. I don't know how familiar any of you are with SPSS or Minitab, but those are distant in those menus. And that gives students the sense that they're different. Yes, they're different. They're analytically doing very different things. Their assumption base is completely different. But they answer a question that's very similar. They're answering a question that we would typically ask in the same platform. And so what I like about JMP is it reinforces this idea that these are all doing the same thing, or these make sense in this context. And the same thing is true on the right. If I'm fitting a line, this is also where I fit other things that model relationships between two continuous variables. And so it's seeing the connection between these things. I think it really helps students to fit together. But if you notice, on the left-hand side, right, the output we got was different than on the right. And that was just to do with the modeling type. And you may have noticed too, remember my point? Click every red triangle when you're first learning JMP. Let's see what's under this one. So now that we fit a line, it's giving us options that make sense. And this is something I would always recommend you tell your students to do. Actually, I would set this as a default for them. Plotting the residuals. So as soon as they fit a line, they can't help but look at the residual bundle. So they get residuals by predicted, actual by predicted, residuals by row, residuals by x, and then normal QQ pop for the residuals. Now, it depends how far you go. In an intro class, that may be a little overwhelming, and so you may want to hold off on that. But if this is an advanced course and you want them to really diagnose the models, that's a great idea to have them turn on. All right, so we went pretty far away from my menu item over here that I was talking about, which was importing data. And so that was importing a text file. Just so you can see, JMP can import lots of different data types. Certainly SPSS, Minitab, R data types, of course text files. It has no problem with Excel spreadsheets. Let me open an Excel spreadsheet here. There's a beautiful interface for this. It's called the Excel Import Wizard. And what I love about this is, a lot of us have, at least my Excel files, I have 12 rows at the start that describes the file. I have all sorts of nonsense in the header. This lets you say, well, where does the data start? You just put in what column and row. And so you can actually, not have to feed it a perfect Excel file. You can just tell it what part to pull in. And also, if you have an Excel file with multiple sheets, we actually do this a lot. So we'll have 10 years of data, all the exact columns, but I wanted to bring it together as one table. You can check all the boxes for every sheet and just merge the columns that have the same names. And it'll actually have an indicator for which sheet it came from. So it's a great way to bring in data. So I'll import this and you can see it brings it in right away. No problem. There's another feature, and this is too cool not to show, because I think for intro stats, the first week I have students do this. It's called Internet Open. And this is probably one of the neatest ways to bring in data. So let's say we're, I don't know, this is a real story. Let's say we're working with ornithologists, and we're really interested in talking about state birds. So let me imagine, we're in class here, and I'm a student, and I want to bring in state birds. So I'm going to go wiki. And you go to this list of state birds, and there's a table on a website, right? And if you want to bring that into JMP, you could try to copy it out of here. It's going to be unhappy copying it out of Safari. Let's take the URL. I'm going to go over to JMP and do Internet Open. And I'm just going to paste that URL. And when I open it, it's going to say, oh, here are the tables I found. Let's just let all of them get open. It's going to have some that aren't right. But there it is, the last table. There's my state birds table. Now this is kind of neat. JMP knows that there's images on this table. And so let's tell JMP to load those images. What's that going to do? We have a data table. How can we work with images? Let me scroll across. Oh, there they are. And so we have the images from the wiki. And let me tell you, there's nothing like bringing images in a table and then graphing with images that gets students excited. And I don't know why. There's no reason it should. Nothing we ever do really, but it's something about the mixed media and feeling like you're connected to your data again. And that's just something JMP can do. I think that's amazing. And just being able to do internet open. I always have as a really early assignment, just find data online and you're going to share it with the rest of the class in about 20 minutes. And they just go searching, usually something to do with sports, or they come up with some interesting questions, and they just internet open, bring it right into JMP. Yeah?
So this looks like the table has to be in some certain format. Like I went to MLB.com
Sure.
and tried to pull that in and it didn't work.
It's got to be an HTML table or XML or set up in the CSS. So it'll parse most web pages.
Yeah.
There's some places that put their data up in really weird ways. Yeah. But and back there too.
I was just going to say that the basic follow-up on her question is that
Yeah.
if it's some kind of picture PDF, do you have like a scraper?
That would be. I was actually chatting with somebody yesterday about this exact question. There isn't an OCR scraper. I've been able to do something that does something like that through integration with MATLAB. So JMP, I didn't even mention yet, but JMP you can connect to MATLAB or R to recruit some of its power, and that's running it through an OCR engine. But no, nothing built into JMP for that, which would be great though, right? To take those old PDF printouts of people's tables and pull it in. So not entirely there, but I mean that's a great feature for that quick bring data in, get people excited. Yeah, question.
I'm using JMP 11. Does JMP 11 not import images?
Yeah, that was a new feature in JMP 12. Yeah, so JMP 12 added it's actually a special type of column, which is called the expression column, and that allows you to have images or actually any type of JMP scripting built into the table. Yes, that was a new one. All right, so bringing data in, pretty straightforward. Now I want to tell you about a couple essential features, and where are we now? 5:05. Am I really out of time? No, I started at 4:30. I talk a lot, I'm sorry, but I didn't want to go over everything just in the basics. Let me hold off on some essential tools though. I'll come back to some of these as I talk about some of the other platforms, because I want to show you some of the essential platforms, the ones you would have to see or will see if you're using this in intro stats. And actually, perhaps the first thing I want to show you is what I do with my students the very first day. Well, after I get them to install JMP, we actually, in class, spend time doing this because I think it's so important that they don't sit at home and try to do it and don't do it, and then a week goes by and they're like, how do I install JMP? No, get it on their computers the first day. And I actually open up, sometimes this data set, sometimes other data sets, but just a data set that has something like states, something like counties, something geographic. And what we do is we go to GraphBuilder. Now GraphBuilder is under the graph menu. It's not built for analysis, although you can get statistics out of it. It's built to show data. And it's built to show data in a really great way that lets you really pour through different columns, drag things, interact with your data. It doesn't stick you to a particular visualization. I think that's great because you have to see the graphic to know if it tells the story of the data. So let me give you an example. So this is what I usually do with them. I say, take region, and I want you to just drag that to the x. And so they drag it to the x. And I say, what do you see? Well, they see just a bunch of dots. There's actually no y dimension here. So what JMP is doing is just jittering the points within the y dimension so you can see them. Now, that may seem useless, but there are times that actually conveys something about the number of observations. You'll actually learn to love that, I think, jitter plot right there. But let's give it a y dimension. So let's give it, we normally talk about SAT total, right? Not verbal and math. So let's actually take both of these variables, and I want to show you something. In a platform launch window, which is what this is, you can grab two of them, right-click, you get a little menu. Let's combine them, make a sum. So now we have a sum that we can use. It's a temporary variable. If you like, you can save it to the data table by right-clicking. But for now, let's just use it here. I'll drag it into y. Now we still have our jittered points. Shows us a little bit about the spread, but look at the ribbon at the top. These are all the visuals that make sense. Remember, JMP knows what type of data we're working with, so it's going to give us things that make sense. It's not telling us we can do a linear regression here. Instead, it says, hey, you can do this thing. This is cool. This is a contour. And so this shows, let me drag the points on. You could actually drag another visual on top. So see what the contour is doing. It's a folded distribution. It's showing us the spread of data, but it's doing it as a nice little smooth curve. Let's turn that off. Here's one that you often use, box plots. That's not bad. See the median? Yeah. Let's keep that one open. We have some other stuff in this data set, like year. Now this is kind of cool. There's some zones, group X, wrap, group Y, and overlay. Those are zones that break up what we're already seeing. So let me take year, and I'm going to hover it. I'm not going to drop it yet. I'm going to hover over X, That's an okay visual. It's a little bit noisy for my taste, right? Let's look at group Y. Less noisy, but useless. Like perceptually, can you tell at all what's going on? I can. But RAP, look at RAP. RAP is pretty neat. So RAP shows for each year the little spread there between the different regions. Now, this is exactly the time when I say, if we want, to my class, if we wanted to show year-to-year changes in a region, is this a good graph? Now think about what perceptually that necessitates. I would have to look from here to 94 right here, to 97, I think right here. That's terrible perceptually. Like you need to have those right on top of each other. So I say, okay, grab year again, drop it in an overlay. Ah, now we have it. I'll click done actually so we make this a little bigger. But now we have these all next to each other. So we'd actually see within each of the different times, right? They may say, okay, well, I would rather have some spaces there. So let's go back. I'll actually grab region out and drop it in the group for X. So now it actually does spaces for us. Lots of flexibility with what you can do. Now here's actually the one I love. I tell them to start over. And I say, okay, well, often we're interested in geography, right? We have SAT scores across the country. Take that state variable, drag it down there to map shape. Now we get a map. Take that combined SAT total, drive it in the middle. There we go. So now we actually have the geography. And there's something about, and I always make this point, the juxtaposition between this table, where they get so little information. I mean, they see the data, but this is a big mess. I like to expand it full screen so they see it's just a noise of overwhelming data points. They don't get meaning from that. And then you click right over to this one. And you say, can you make meaning of that? And of course you can. I mean, geographically, we can see where the highs and lows are. Right? That tells a story without much effort. And I think that juxtaposition the first day or the first week makes people feel the value of data is worth their time. And it's also play. There's nothing more fun than just playing with these variables. We can take another variable like year. Let's drop that in the wrap section. And then my students say to me, but Julian, perceptually, or Dr. Julian, I think they call me, perceptually isn't that bad because we can't see California changes over time. And I say, yeah, that's true. Let's actually play with this. I'll right-click, levels in view, I'll do one at a time. Now we can click through, little interactive window there. This is really cool. Anytime you have lots of levels of a variable, or let me go back to all, and I showed this yesterday. This is a new thing in Jump 12. Click on the red triangle. There's this option, make this graph into a data table. Okay, what's that going to do? Let's run this. We get a data table, little tiny plus there. Let's drag the row heights out. And there we go. We made a data table of the different years that we can scroll through. Really cool. And so we use this all the time. I mean, it seems like kind of a toy feature, but when you have, I do a lot of research consulting, and friends have 250 subjects in their data set, and it's not a map for each person, but it's some kind of regression, something individual. And for every individual subject, they can actually put out a plot of some relationship, something within subject. And so showing the data becomes a lot easier. And so that's just an option in the GraphBuilder. And so GraphBuilder is worth playing with. This is actually an iPad app as well. So if you just have your students get their iPads out the first day and put some data in Dropbox, they can play with it too. The one on the desktop is so much better though. Being able to click and drag and get their own data, I think is really, really fun. And all the types of visuals that make sense. Dragging two quantitative variables, you have different options. So just like most things in Jump, very sensitive to your data. All right. Now let me go back. There's one more thing I want to show about GraphBuilder, and this is just neat. If you ever have data like this, data with latitude and longitude, and this was due in Jump 11, but these are San Francisco crime data, and so this is only for, I think, like a week, so 9,000 something incidents. There's a newer version of this data set. It has the my car break-in in it. This is like last December. It was kind of fun to find. But anyway, so let's go to GraphBuilder. How are we going to make sense of these data? Well, we can do a number of things. First, and this is one that I really like, using a heat map. So let's take time of day. I'm going to put that on the X. If I can grab it. There we go. Time of day. Okay, I get a big box plot. That's weird. Well, let's take day of week, drop it on the Y. Going to get a bunch of box plots. But look at this little heat map icon. If I click on the heat map, look at this. So this is, across time and day of week, a heat map of the number of incidents. And there's a lot of meaning right away there, right? We can see, between 3 and 6 p.m., there's some real hotspots, especially Friday, between 3 and 9 p.m. It's really the highest counts. When do you want to be out in San Francisco? 3 and 6 a.m. Although a student of mine was very quick to point out, this should really be scaled relative to the number of people on the streets. And I said, very good point. which is true. But you can do lots of things with this. I mean, we could do this by police district. Put this as a wrap. That's actually a great way to see it. And so we can quickly see, well, okay, there's a lot of stuff happening in the southern region. The rest of it's pretty okay. But what I really wanted to show you in this data set is this. So let me go down to latitude and longitude. I'm just going to take them both and drop them in the middle. And for any of you who work with maps, you're going to say, but Julian, latitude should be on the y-axis. And you're right. So I'm going to right-click, go to swap, and swap it. This is actually a really useful thing. Every time you put it in the wrong place, being able to swap is easy. And you might say, what are we looking at here? There's a big cloud of points. Let me right-click, go to Graph, and go to Background Map. And what I can do is have this connect to the Street Map service and pull down street maps of this. And this is so neat. So let me go to Tools, and I'll go to my Zoom magnifier. Let's just zoom in here. And we can get down to street-level detail for crime incidences. And this is neat. If you ever have data that has latitude and longitude, there's actually, in the talk yesterday, Brent Deppel was talking about Redfin. Gives you, it's just like Zillow, it's data on housing. And they come with latitude and longitude. So you can have students download from their own home zip codes the housing data and plot them on a map. And because everything in JMP is linked, you can still select these points. We can just hover and see what was going on. So that was a vehicle theft. Some of these are fraud. There's a lot of fraud in San Francisco for some reason. But so I think this is just a great way to get people excited about data. Seeing a map for some reason really does it. Whenever you're done with these, I clicked it before, but I'll show you again. You can click Done, and this is something you can save out as a PDF. I haven't shown this yet, but you can actually export these out as interactive HTML even. So on the Mac, it's going to be under Export. On the PC, it'll be under Save As. This is most useful in platforms like Distribution. So you remember Distribution had that really cool feature where, this is a weird one to show. Let's do a different one. Distribution, I'll do, let's see, police district. Let's do traffic incident or not, day of week. So we get 3 little histograms here. But remember, they're interactive. Remember, I can click on these and see them all. But this is a great thing to export out. So if I go export, and on PC again, it's going to be save as, interactive HTML with data, this will actually encapsulate the data and an interactive HTML format that allows me to open in a web browser. If I can find it on my desktop, we'll clean up by name here. Aha, hidden. Opens in a web browser, still interactive. And so this is something you can share on a website. Your students don't even need JMP. I actually have them do this for their final projects. And so I was telling the story earlier, grades motivate students, absolutely. But fear of being embarrassed in front of their peers really motivates students. And so actually for their final projects, I had them do a little experiment in my honors class, and they had to put their data online and share it with friends. And they were totally willing to share it with friends, because these are little experiments they've been working on, they came up with. But one of the students told me afterwards, he really said, he's like, knowing that my friends would be looking at my data online and thinking about what I was asking and what my questions were, really made me work hard, because nothing motivates them like not thinking their friends are going to think they're smart. So I think it's a great way to motivate them. Plus, their friends can click on the data, and so even if their friends don't know statistics and don't have JMP, they can interact. And there's something about touching the data, interacting with it in that modality that's really powerful. And so it's a neat thing to do. I think it must have taken our programmers so long to do this. This is just so cool. So I'm always excited about that. And also for a practical reason, anyone who publishes, put your data in an online appendix as interactive HTML. Then people who read your papers can actually go to your online appendix and click through. And it really makes publishers happy, the whole idea of sufficient statistics and showing your data. It's a really nice way to show off. All right, so that was GraphBuilder. And so a really nice place to start with students. Where am I on time? I'm especially loquacious today. 5:17, cool, 15 minutes. I want to show you Tabulate very quickly. And then we'll move on to distribution and fit y by x. And I might as well just bring up the same data set I brought up before, restaurant tips, because this might be one, you just want some tabulation. You want to know what was the total number of, let's say, total amount of bills for Monday through Friday, or for different servers in your restaurant. And so let me go to Analyze, and I'll go to Tabulate. And in Tabulate, just like GraphBuilder, there are drop zones for different rows or columns you want to use. And I always say for this one, imagine the table you want, and then drag the rows into place. And so I'm imagining a table where I have a column that just says total or sum for bills, and I have rows that are the different days of the week. All right, so my rows are going to be defined by day of week. So let me drag day of week over here. Notice it gets highlighted. All right, the first thing it does is shows the number of observations. So there was 20 observations in the data set for Monday. There was 13 for Tuesday. You can even click them. They're interactive still. But remember, I wanted a total of bill. So let me take bill amount, and I'm going to drag it right here in the middle. A little drop zone there. So I want to replace what's happening for n. And actually, sum is the default. It didn't just read my mind. That's actually what it does by default. If you want to change that, you can right-click, go to statistics, change it to whatever you want. Maybe I wanted the average. Or maybe I want both the mean and the average. So actually, or mean and the total. So I can go down to sum here. You can drag in. Now watch what happens. If I hover over the middle and drop there, it replaces it. That's what it means in jump's head to hover over the middle. Let me undo. I'm going to drag sum again. And look what's on the right-hand side. There's a little teeny drop zone there. Or the left-hand side. That's the prepending and appending drop zone. So let me append to the end. Mean and sum. That's a pretty good table. But let's make it even more complicated. Maybe I want to break up day of week and server. And so I have server over here. Let's take that over to day of week. Remember the little heuristic? Dropping on top replaces. Dropping to the right or left appends or prepends. Let's prepend. And now I have server and day of week. And maybe I think to myself, actually, I want server to be different columns. That's the table I'm imagining. So let me grab server. Remember, holding on the middle replaces. Holding on top or bottom now is the appending or prepending. So there it is. There's some points missing. What's going on there? They weren't working there. Yeah, perfect. And so even this table can give you insights into your data set. And I actually use this sometimes for weekly cross relationships. So when you're doing factorial ANOVA, sometimes you need to see, do I have enough observations in every condition? And you can make yourself a little table to check that. Once you're done, you can just click done. Or, and this is neat, the red triangle, remember, click every one of these. You can make this into a data table. Right now it's a little jump interactive table, but you can make it into its own proper data table. Now why is this useful? Let me give you one example, then we'll move on. That SAT by year data set, remember the one that had different years and we had lots of SAT scores? Let's imagine we wanted to run a regression. We have 8 rows for every state. We're going to multiply degrees of freedom by 8, and we shouldn't, right? Because these 8 rows are not independent. So we need to tabulate. We need to average over the SAT scores from these 8 years for every state if we wanted to run some regression. So let's try this. I'm going to go to tabulate. Let's imagine the table. Each state will occupy one row of their state. We want SAT total. Remember the trick. I'm going to grab them both, right-click, combine, take a sum. Let's take the sum and drop it in the top. Remember, we wanted to have the mean, so let's right-click, take the statistics, make a mean. And let's say we want to do a regression with expenditure. Remember the trick. On top, replaces. To the right or left, appends and prepends. There we go. Final thing, remember that red triangle? Make a data table. Now we have an aggregated data table. So now we can actually do our regression. So look at SAT scores by expenditure. And there we go. And so this is now averaged over years, so our degrees of freedom actually make sense. Now this should be a very concerning plot to you, by the way. SAT scores by expenditure. So states that spend more are actually getting lower SAT scores. Turns out there's some good reasons why that is. It's actually states that require more people to take the SAT tend to get lower SAT scores. And those also tend to be states that spend more in education. So the states that require them. Or states that use ACT, not SAT. But point here is that Tabulate is not only a good table creation platform, but it's also good when you're doing those aggregations. So taking sums or averages over variables. All right, so that's Tabulate. Now, we already looked at distribution. Distribution was that one variable platform. Really good whenever you have univariate questions. And in fact, my advice is every time you get a new data set, we'll go back to, let's go back to restaurant tips. Every time you get a new data set, the first thing you should do is go to distribution, and I would tell your class this. Take every variable, put it into Y, and click OK. And now go through variable by variable and make sure things look OK. It's the best way to catch errors. So for instance, you may see bill amount here. There's a huge bill. If you don't like that, you can right-click and exclude right away, and that'll take it out of the data set. It actually puts a row state that excludes it here. So if I scroll down, you can see there it is, hidden and excluded. Hidden means it doesn't show up in new analyses. Excluded means it doesn't get calculated in summary statistics or statistics for that row. So I can go back and hide and exclude, which brings it right back. Now my point about this is to screen your data, it's a really good idea. Just scroll through, it's so easy. And it's a great thing for students to get in the habit of because they'll actually see more about their data and the structure of the data and really take advantage of that interactivity. Get them clicking on things and sort of exploring. If you want to run one sample tests, remember the red triangles, testing probabilities, that's a one sample chi-square. If you want to, I'll just do it here for server, test probabilities, level A, B, and C. Now, there's a trick, third, a third, a third. That's going to be a lot of decimal places for me to type in if I want to type in 1/3. Now, instead, JMP will rescale. So if I do 1, 1, 1, JMP knows, well, you can't have 3 for probability. So hit done, and it scales it for you. And so a third, a third, a third, and we get that Pearson or likelihood ratio. So our goodness of fit chi-square right there. I showed testing a mean before, but I'll show it again quickly. So test mean is under any continuous column in distribution. And so here, under the null hypothesis, let's imagine that tip percentage used to be 16 last week. And let's say we also want that non-parametric. I actually have students check this all the time, the Wilcoxon sign rank. We can have produced right at the same time. We always get a graph with every statistic. Now I want to point out something. There's the test statistic right here for Ttest. There's the sign rank. Now the two-tailed p-value in JMP is probability greater than the absolute value of t. That's the way it's written. And these are the two one-tails, the directional. So one tail positive, one tail negative. So the two tails right here, that's what I usually point my students to. And the nice thing about showing this is you can actually have them look at the sampling distribution, at least asymptotically, and look at the shaded regions. And that is the p-value, at least the two-tailed p-value. So a nice way of driving home the relationship between that and the actual test statistic. All right, so that's distribution. That gets you pretty far. That's probably the first couple weeks of an intro class. But fit y of x is really where you're going to be going after that point. And as we saw, fit y of x has that contextual layout. So it will produce different analyses based on what you put in. And we tried this before, but I'm going to do it all at once. I'm going to say let's predict bill amount based on credit card and number of guests. Now it may look like I'm running sort of an ANCOVA here. I'm not. Fit y by x will always do bivariate outputs. So what it's going to do is produce in the same window two separate outputs. One fitting bill amount against credit card use, and one with bill amount against number of guests. And remember, JMP is contextualizing the output. So when you're teaching the Ttest, that's going to be in this context. A nominal column on the x and something continuous on the y. So let's look at these. So means ANOVA pooled t. So this is the pooled Ttest. It assumes equal variances. So let me run that output. Now you're going to get a lot of stuff. I usually hide the summary of fit and hide the ANOVA table if I'm doing it this way. I keep the means for the ANOVA, that's fine. And you get the Ttest in the same format as we saw before. The difference, you're going to get the t ratio and a proportion greater than the absolute value of t for the two-tailed p-value. Now, I want to go back though because there's the other option, Ttest. And this will synthesize the degrees of freedom, so it's not assuming equal variances. And it even hovers and shows you. So this shows or hides a Ttest only available at 2 levels. Oh, it should say not assuming. There it is. So assuming unequal variances. And so it's nice to actually print them both out. You can actually show them the differences in t ratio. You can say, look, the difference is identical, but look at our standard error and look at our degrees of freedom. And so they can actually see the changes here. Now formally, you often want to test whether your variances are equal. And remember, JMP puts things that are related really close to each other. That's in the same context. Unequal variances is right there. And so if you're doing a t-test and you're trying to decide unequal variances or not, well, run the unequal variances test and you get multiple outputs. So the f-sided or f-test two-sided only when you have 2 levels. The rest of these are really nice. I like the Brown-Forsyth. It makes some few assumptions. Levine's is really good too. Doesn't assume normality in testing unequal variances. It always seems strange to me to have assumptions for the test of assumptions that you're running. But Levine's is a good one for that. But at least students can see there's different ways of conceptualizing that test. And the plot's nice too, standard deviation for the different groups. All right, so that's on the left. That takes you pretty far too. We just did Ttest, that's also where you do ANOVA. On the right-hand side, that's where you're going to be fitting your lines. That's a continuous variable against a continuous variable. And typically, when I start teaching this, I'll have them fit the mean first. This is actually kind of neat. Fit the mean, and you actually get the sums of squares error about the mean. That's the corrected sums of squares total, which is kind of neat if you ever get into more advanced regression, so you can see the deviations from the grand mean. But usually what you're fitting is actually that line. It's a fit line. And so that'll give you your summary of fit, your R-squares, all your details, your analysis of variance output. So we're talking about the overall model. Typically, we're talking about parameter estimates. And so we'll get them here, the estimate, standard error, and the p-value. I want to talk about something in general in JMP. When you have these tables, try right-clicking and go to columns. Because if you go to columns, you'll see some things that get hidden by default that honestly most people don't want to see until they really want to see them. Things like the variance inflation factor, things that relate to multicollinearity or design standard error. The one you may want would be lower and upper 95% confidence intervals. around that beta. So if you want the actual, I'll just turn them on here. So columns lower 95 and columns upper 95. Now again, if you always like those, go to preferences and set it. Make jump work the way you want. I actually prefer to have standardized betas on too. And so that's giving you the standardized coefficient, as if you z-scored both of the variables. All right, so that takes us through Ttest and linear regression. Now, there's one final combination I'm going to show, which is what happens if we have something like day of week predicting server. All right, that's a contingency. 3 minutes, says Kurt. So that's a contingency. So that's when we have categorical by categorical. And I wanted to show this output because this is probably one of my favorite things that JMP does, but it was weird the first time I saw it. And what you're looking at here is a mosaic plot. How many have seen a mosaic plot before? Okay, cool. Some of you have seen it. So it's showing 3 things all at once that I think is really special. It's showing the marginal distribution of both variables. So what proportion of the data set have A, B, and C for servers? What proportion of the data set have Monday through Friday? And it's also showing contingent distributions. What proportion are A, B, and C servers per each day? So the marginal distribution of server, that's pretty easy. That's A, B, and C right there. So I'm just selecting them. And that's the share in this big fat bar. So most are B, some are A, and very few are C days. Now, the marginal distribution of day of week is a little harder to see, but look at the spacing on the x-axis. Monday is kind of small, Tuesday is tiny, Wednesday is fat. Right? These are representative of the share. The area of this, or the line width, is really related to the share of day of week. Now, internally is really the magic. On Monday, we just had server B. On Tuesday, we had A and C. On Wednesday, it was A, B, and C. The internal geometry there, or the share, if that doesn't match the average, that's evidence against independence. Right? So these are, in this case, pretty dependent. If I minimize the contingency table, you can see your Pearson or likelihood ratio. But what we're seeing is that the distribution of server depends on which day of week we're in. And you can see that visually. For Wednesday, Thursday, Friday, they're kind of the same, but Monday and Tuesday look totally different from the average. Now, again, under the red triangle, click every one of these. You have lots of things you can turn on. Measures of association is pretty typical. Get some effect sizes for that. There's lots of other options there as well. But I think the contingency plot is a really neat way to look at those data. All right, so I got like a third of the way through this. No, actually I got pretty far. So fit model and multivariate are really neat. There's some videos I'll point you to for that. But as far as resources, I already talked about these guys, the learning library. Concept discovery modules, I hope some of you saw yesterday. I pointed out a couple of them at the start of today. Those are again under the sample data directory, under the help menu, and they're under the teaching scripts, either interactive teaching modules or the teaching demonstrations. And like I said, I'll be putting this video online. Let me show you where that is. If you go to the JMP academic community, so it's community.jmp.com/academic, or just go to community.jmp.com, and I'll show you how to get to it. Go to other communities, JMP academic community. And so we're actually going to put it online here under the Academic Resources Center. And so we'll actually put a link to, we have a lot of things actually from yesterday. We have the links to, we have the webinar recordings. I think we have our exercises for USCOTS 2015. And so I'll put a link in here. So again, the way to find that is if you go to the main community, and then go to other communities, JMP academic community, and then on the right-hand side, there's a section for academic resources, right there. And so I'll make sure you guys can find it. I would say look at the video to find the video, but that's a little recursion, so we can't do that. Okay, so I'll stop there and take some questions. I already told you guys I would stay longer. I know you've already spent an hour listening to me. But yeah, let me take some questions real quick, and then certainly anyone can go if they need to.
What's one thing you can do with the add-ins?
What's one thing you can do with it?
With the add-ins, can we include more stuff?
Oh yeah, absolutely, yeah. So yeah, basically under the file exchange here, there's plenty of things you can add into JMP. Yeah, there's a lot of really neat things. Some of them are games. Some of them are advanced things that were done for industry. The add-ins that we support are the ones that teaching modules. We have a randomization testing add-in, really neat. Lots of neat stuff here. JMP has a lot of extensibility, and I already mentioned you can actually connect to R or MATLAB, so you can do a lot of stuff with it that you like. Some of my favorites are interactive binning, so binning things interactively. It's kind of neat. So if you take something like bill amount, you can actually define which sections. So I can say set cut points at percentiles, and it'll actually make percentile bins. Lots of cool things you can do. Yeah, and they're all free. Yeah. Yeah.
I don't know if you can answer this question, but we have SAS, we have we have Minitab, we have R. I only use Minitab. Can you, in a little synopsis, tell me what the differences are?
Sure.
Okay.
In terms of scope, I mean, JMP will go very far. I always say a z-test through a neural network. So JMP is very expansive and very deep. I think probably the biggest difference would be the philosophy of the analysis. You know, Minitab, SAS, SPSS, really I would say most statistics software on the market was built at a time when we needed to have that server-client relationship. And so they're built in that structure. You produce an analysis, you get an output. You know, even R, which was really built that way, didn't have to be, but that's how it was built. You produce an analysis and then it's flat. So JMP is very different. I think that's probably the biggest differentiating factor is that JMP is built around what I always like to just call interfaces. I mean, these are little windows to your data that lets you connect to it and interact with it. As far as analytics scope, I mean, it's really quite comparable. JMP goes really far if you want it to. So classification and regression trees for data mining, neural nets, you know, all the time series you can ever want, multiple correspondence, item analysis. I mean, these are all in here. So I don't think it's a question of scope. It's certainly not for an intro or mid-level class. Though JMP is one of these pieces of software that they can learn and is friendly for introductory stats, but they can take through their doctorate. And I think that's actually special. You know, there's very few pieces of software that I think cover the graphing and visualization as effectively and sort of as interactively and beautifully, but also do the analysis, and very few that take them from the start to the finish. And I say that not representing JMP. I work for JMP because I love JMP so much, and I spent most of my grad career teaching people JMP. They should have been paying me. I always tell them this for years, but they weren't. But yeah, I think it's special because of just that feeling of connecting either data, and that's really the biggest difference. Yeah, in the back.
Julian, can you talk a little bit about the packaging and pricing options?
Sure.
For example, I work at a high school level.
Yeah. So actually, maybe let Kurt talk about that a little more. He knows more about the SE packaging and pricing.
Yeah, there's a student edition product, limited product, covers all stuff that's here. And we have that in textbooks. We also, for high schools, sell that as a school-wide license that can be installed on the computers on campus. It's a 5-year license, and it's $495.
What about for college level? The same?
For student edition, yeah, we have student edition. You can the pricing I'd have to talk to the sales department about, but I think it's available for schools, but usually at the college level they get it in textbooks. That's really the typical way that it's distributed there.
I think I just looked up and like for $30 they can rent it. Can I see that?
Yeah, we do have also an option to rent JMP for 6 months for $30, or 12 months for $50. That's correct. And we do also have site licenses if you're interested.
You'll just mention for a lot of schools do the site license because you actually get JMP Pro with that. Now, certainly that goes beyond the scope of most introductory classes, except if you're going crazy with them. But the benefit is, researchers typically buy into this, and so it's not something that your students have to shoulder the burden of usually. Most campuses, I think it was like 80, 70%, charge nothing for their students to get it. And the great thing about the license, and I just think this is amazing SAS does this, is it's at home for students as well. So they can put it on their home computers, as many copies as they want, which means they're taking their data, and I think this is just the right way to do it, home with them and playing with it. Because if students have to go into a lab to work on data, it's not the right mindset. And I always say play with it, and I'm very deliberate about this because if you're playing, you're reconceptualizing what you're doing as fun. And even if you're tricking them into thinking it's fun, that's fine. As long as they're playing and they're exploring and they're not stuck behind the math and they're thinking about the value of the data. And that's something I think JMP always brought out in students more than I've seen other software bring out. They see the graphs, they see how pretty it is, they can drag and drop things, so it's so familiar that they just start playing. And I'm amazed. The first week of class, they are mostly doing GraphBuilder, and then we have a project where they bring in their own data and they talk about 2 to 5 minutes just showing what they found. And people figured out all sorts of stuff I never showed them. Some people figured out how to, this is so neat, you can take multiple types of data and layer it. So you can make these big trellis plots of different variables. And so people would come in with these really advanced interactive things. I'm like, how did you figure that out? They just like, oh, I drag things around. They're just playing. And I think that's great. I think that's the right mentality for data. What we do with data is very serious sometimes, but the approach to learning it needs to be, I think, more friendly. Because once you're behind all the values and numbers and formulas, that scares them away, and it shouldn't, because statistics is the best class to teach. You all know this. You're here. So they should enjoy it, and I think most students would enjoy it if they had more play in their class.
So along that line then, kind of purposeful play.
Yeah.
It sounds like you, tell us a little bit more
Yeah.
about how you arrange things so that their play is purposeful.
Right. Almost always I do it in little groups. I find that to be less threatening. If they have to present especially, there's nothing like getting up alone and talking about what you did that scares the crap out of them. But in little groups, what I like to do, I'll give them the same data set and something rich enough where I don't have a lot of the ones I use here, but rich enough where there's lots of columns, lots of data that they can play with. And it's like 15-minute assignment with groups of 3. Find something interesting, find a way to display it, and be sure that you can convince us why you displayed the data the way you did. And that's a really early on one. Getting them to get out of this mindset of, okay, I have these data, what's the best visual? Which is the wrong question always. It's what visual tells your story. And so as soon as possible, I get them into the mindset of, okay, well, what can I find in the data? So they explore, and they have 15 minutes. So in groups of 3, that's not a huge amount of time to explore, but enough where they find something interesting, and then they put together a graphic, and then basically 5 minutes they have to get up and give a little talk on it. So that's one little activity. I like later on in the class, not in the beginning, I like to give them increasingly bad data. And by that I mean data that starts off pretty, this is pretty data. But for instance, I showed a little of this yesterday. Later on I want them to get data that has a couple things that are wrong. And they, by the time they get these data sets, have heard me say, what's the first thing you do? And they say, run distribution. I'm like, what's the first thing you do? They look at distribution. And so they know they're going to open distribution. They're going to put all the columns in. And I hope they find these things. They have in the past. They get down to credit card and they say, oh, well, something's wrong there. The no's and the ends. And then they get down to things like day of week, which is just a whole mess, right? And I think that's great because, real data is much messier than this. Anyone who's done a study or done a survey, knows that people come up with uniquely wrong ways of answering your questions. And, this is a pretty trivial example. But I want them to see that because there's great things in all software that helps you clean it up. But JMP has some really cool ones. And I'll just point this out. This is new in 12. If you haven't seen it, under columns, under utilities, there's a recode facility. Now recode has always been in JMP. But JMP 12's recode does something really cool. So look at this. This is just so messed up, right? We have Fridays, we have spaces, we have all sorts of stuff. You can grab levels. You can right-click and combine them if you want. But this is something that JMP can figure out. So go to their red triangle. Remember, click every red triangle. Go to group similar values. And this is just magical. So it can ignore all these things. Difference ratio says, what proportion of this word, whatever word we're talking about, can I change as JMP to make one word another word? And a quarter means, okay, a quarter of the length of the word. Let me click OK. Look at this. It figured out that all those group together, except for Wednesday and the rest of the WEDs, because they're so far. So I'll hit group for those. Now I'm done. I just recoded like 15 levels into the levels they should be. Now, there's a couple things in this menu. So done in place writes over the column. Don't ever do that. What that'll do is that'll write over the column, which is really okay, but honestly, you can never go back. And so if you don't catch an error and you've saved your file and it's a month later, you have no way of going back. So do one of the following. Do new column, or, and this is what I always tell students, and you should probably do too, is formula column. Watch what this does. It's going to write a column to the data set, which has the recoded values, but the way it's doing it is something special. So let me scroll down to the bottom, because what it's doing is recoding dynamically. So if I type in lowercase WED, which was one of the errors, look what it did. It recoded it still. It is online or active recoding. And the way it's doing it, let me right-click and go to formula. So columns as a whole take on formulas. It wrote some conditional logic. So it wrote a match function. If you double-click this, this is actually JSL. It's part of the scripting language. But let's just look at it graphically. It says match the day of week column. That's why it's italicized. And it says if I find this, make it this. If I find this, make it this. If I find this, make it this. And so it's online recoding. And this is great because this is your recoding schema too. You can show this to somebody and show them this is how you recoded. So yeah, as far as assignments, though, going back, increasingly bad data. I think that's a great training for them and worthwhile. And that's one where they can do it in teams of 2 or 3. Give them a bad data set, say get it to workable, and we'll come back in 10 minutes.